So then we have hybrid electric vehicles. So here what happens, there is a IC engines. This is a primary device, okay. Internal combustion engine is a primary, and there is an electric assist, okay, both electric motors and the petrol engines, okay, both will support for the moving the vehicles, okay. And here the battery charges via regenerative braking only, okay. Here there is no you cannot charge the battery from the external modules like charger modules or domestic commercial chargers, okay. So here the battery will be integrated, and the battery will be only charged by using the regenerative braking and the IC engines, okay. You can take the example of Toyota Camry hybrid, okay. This is a hybrid electric vehicles. Then there is a fuel cell electric vehicles, where the fuel is hydrogen fuels, okay, to generate the electricity, okay. So here there is no there will be no batteries. So here there is a fuel called hydrogen, okay. So which is like where the hydrogen fuel will be reacted in the module, okay. There the electricity generated, that generated electricity will be fed to the motors, okay. Here the in the exhaust there will be no carbon dioxide, no oxygen. Here there will be water in the exhaust, okay. You can take the example of Toyota Mirai, okay. This is an example for the fuel cell electric vehicles. So this vehicle is still on the research side, and also there are some vehicles running already based on this fuel cell electric vehicles, okay, but they are limited, okay. And this is the future. Hydrogen fuel is the future, okay. When it comes to the electric vehicles, the battery needs raw materials like uranium, okay, and also some minerals which are very rare, okay. So for based on that data, the hydrogen can be the future, okay. So not electric vehicle engines, okay. Electric vehicles can be used nowadays, okay, and it can run up to 20 years, 30 years. After that we will switch into the hydrogen fuels, okay. Yes. So here you can see the electric vehicle working. So first there will be a battery pack, okay. Then we have a BMS. This is a main module, okay, because if there is no BMS means the battery life can be degraded, okay, and battery may damage, okay, and the range can be reduced. Overall the battery health will degrade if you miss that BMS, okay. So what this BMS will do means, so it will monitor the battery, okay, battery current, battery voltages, okay, and battery temperature. All these will be monitored by the BMS, okay. For example, if a battery temperature is more than 35 degree, 40 degree means it will cool down using the cooling systems, okay. For that all operation we use BMS, okay. And then we have inverter and controller. So if the electric motor is AC means we will convert it power to the AC, or else electric motor needs higher voltage means we will these controllers will convert that energy power into more, okay. And then there is a electric motor, okay. So based on the applications they will use multiple types of motors, okay. And then drivetrain and wheels, okay. So which are connected between road and the vehicles, okay. That is called as drivetrain. Here there is working of the battery, okay. Battery here it provides high voltage power, okay, 200 to 800 volts. You can get the power supply from the batteries. And then BMS, so it monitors the voltage, temperature, state of charge, okay. All these will be done by the BMS. Then inverter. So inverter, what it will do, it will convert DC into 3-phase AC or required supply, which is required supply for the motors, okay. And then motor converts electrical into mechanical torque, okay, that everyone knows about that. PWM switching in inverter controls the motor speed and torque. So here, especially when you are controlling the motor speed, always we need to use the PWM switchings. Okay, PWM is nothing but pulse width modulation. So using this signal, you can control the motor speed and torque. Okay, yes. So like next is field oriented control. So which decouples the DQ axis currents. Okay, so when there is a high current or the current which can damage the equipments, so it will avoid these circumstances. Okay, next, gear reductions transmits torque to wheel efficiently. Okay, so here what happens, if you need high torque, okay, you will switch it to the first gear. Okay, like that. Then if you need high speed, you will switch that gear to the fifth gear. Okay, that is top gear. Okay, you can tell it like that. Okay, based on the torque, we will change the gears. Okay, so where we require high torque means when you are going in low speed. Okay, when you are going low speed, you need high torque. Okay, and when you going in speed, you require very low torque. Okay, because there will be a high speed. Speed will be high. Okay, and the gear shifting will be at the fifth gear. Okay, so where the torque is less. This is done using the gears. Then there are throttle pedal maps to torque demand in the real time. Okay, and this throttle will increase the voltage across the input of the motor, and that motor speed can be controlled using the throttle pedals. Okay, all these electric vehicles have these two pedals. One is braking, one is accelerating. Okay, and here heavy powertrain key components. So these what are the key components? One is battery pack. Okay, next electric motors and vehicle control units. Okay, here what it will do means it will control all the vehicles bodies. Okay, vehicle equipments like headlights, engines. Okay, engines is nothing but motors. Okay, and regenerative charging system, communication for the, like communicating another devices, another vehicles, communicating to traffic managements. Okay, all this done using the vehicle control systems. Then there is a power electronic converters where the power supply and PWMs or PWM signals can be generated. Okay, then we have BMS, battery management systems. Then thermal management. So this thermal management is required for the huge vehicles like trucks, okay, trains and all, because there is when there is a high voltage, there is a thermal heat generation. Okay, so for cooling purpose we use liquid. Either you can use liquid, either you can use oil cooling, either you can use radiator fans, anything. Okay, so what are all the cooling equipments, these will come under the thermal management. Next, braking electric vehicles. So here we have two types of braking. One is conventional braking, one is electric and regenerative braking. Okay, so what like in a conventional braking, here what it will do means here there will be a brake pads, clamp rotors. Okay, here if the motor is running in high speed means if you push the brake means there will be brake pads. Okay, which will compress that brake what you say yes, wheels. Okay, so that the pads will compress and the speed will be reduced. Next, there is a kinetic energy, heat which is wasted. Okay, so here simple, here there is no option called regenerative braking. Here if you apply brake, there will be energy loss. Okay, what type of energy loss? It is a heat. Okay, only heat. And here rotor wear causes maintenance cost. So if you suddenly press the brake pedal means the motor will get high load. Okay, because you are holding the rotation. Okay, so you are applying the load to the motor. That's why. So there wear and tear can be common. Okay, and then energy dissipation is non-recoverable. So here if you vehicle is moving in high speed means if you press the brake means there is a loss of energy. Okay, there is no recovery. Okay, and then brake fade at high temperature reduce the braking force. and if there is high temperature in the brake pads, okay, it will not work efficiently. There will be a it will take long distance to stop the vehicles. Then ABS modulates hydraulic pressure to prevent lock. So here what happens, the module called ABS, anti-lock braking systems, which are used in all the vehicles nowadays. Okay, so in from bikes to trucks there will be ABS. Okay, what it will do means it will avoid the wheel to lock. Okay, it will brake for some nanoseconds, and it will give leave the wheel free. Okay, again it will lock, again it will leave, again it will lock, leave. Like this ABS will work. Okay, which avoids the vehicle to skid on the roads. Okay, or else it will keep the vehicle in stable, okay, on the road. That's why we use ABS, and it acts as a better efficient braking systems. Done. Next, regenerative braking. Here the motor acts as a generator. Okay, and here the kinetic energy can be converted into electrical energy, because so motor will act as a generator. Okay, free energy, if the wheel is running in free means, then you can convert that free energy into electrical energy. Here reduces mechanical braking wear significantly. So when you switch the vehicle into regenerative braking, so already the braking will be applied by the motor. Why? Because it is acting as a generator. That's why. Okay, so there will be a high force on the motor. Okay, so which will also brake the vehicles. Okay, it will brake the speed of the vehicle. Next, energy stored back into the battery. Okay. Again, generated energy will be fed to the battery, and battery gets charged. Next, blended braking, regional friction as needed. So here what happens? Here the regenerative, when the vehicle is regenerative mode, there will be a braking applied by the driver and plus regenerative braking. Both the brakings can be applied at the same time, and vehicle will stop at a minimum distance. Okay, and next, one pedal driving possible in EVs. So one pedal is nothing but you can use it for acceleration. That's all. Okay, acceleration pedal. You can drive the electric vehicles using only one pedal, that is acceleration. If you leave the acceleration, the motor acts as generator, and the vehicle speed will reduce. Okay, it acts as a braking okay, so you can skip that braking pedal. You can only use the accelerator pedal in the regenerative braking systems. Okay, all these benefits you can take in the regenerative brakings. Then here we come the concept called regenerative braking. Okay, now so what it will happen means, the vehicle kinetic energy is converted back into electric energy instead of wasting it as a heat. In a normal vehicle, if you apply the brake means, it will reduce the speed. Okay, and that energy which is generated from the wheels will be wasted, okay, as a heat. So in many situations you can see, okay, the brake pads will be hot, and the brake will not work. That's why the vehicle will be stopped for half an hour, 1 hour, and then they will start the vehicle to move. So that can be avoided in the regenerative braking. So here how it will work means, first vehicle is running at high speed. If you put the vehicle into regenerative braking means, it decelerates the vehicle. Okay, it will slow down the vehicle. Then wheels drive motor shaft. So here what happens in the normal condition, the motor shaft will run the wheels, okay, or tires. But here when it comes to regenerative braking, the wheels will rotate the motor. Okay, that's why the motor acts as a generator. In the normal state, you are supplying the current power from battery to motor, but in the regenerative case, you are supplying the power by the from the motor to battery. Okay, like that. And here inverter rectifies the AC to DC. If you are using AC motor means, it will convert it to DC, and the energy will be stored in the battery. Okay, done. So and here you can see the efficiency, energy recovered in the city driving. Okay, city, if you are driving the vehicle in city, means the energy recovered is 10 to 30%. Okay, and if you like vehicle is in regenerative process, regeneration process, 70% energy can be used, and it is converted into electrical energy. Okay, then 50% reduction in brake pads wear. Since the regenerative braking motor is applying the brake, you no need to use the brake pads. Okay, no need to use the brake pads means the brake pads will not wear and tear easily. Okay, it will extend the life of the brake pads. Next, range increase versus so here what happens if you use regenerative braking means the range. So if your vehicle range is 100 kilometers when you charge the battery to 100%. So if you are using regenerative braking means the vehicle can go up to 120-130 kilometers on the full charges. 20 to 25 kilometers can be increased. Okay, when you use the regenerative braking. So here there are two operations. One is motoring mode and generating mode. This is a mode of the motor. Okay, on the wheels. When the motor is acting as a motor, here what happens, acceleration and the normal drive. This is the situation. Okay, so here what happens, inverter applies 3-phase AC voltage to the stator. Okay, and rotating magnetic field creates the torque on the rotor. Sorry. Okay, so this is a basic motor working. Okay, mechanical output power is equal to like theta into omega. Okay, na? Then the battery energy is converted into kinetic energy of the vehicles, and current flows from the battery to inverter to motor. And when it comes to regenerative mode for the same motor, okay, so here what is the situation, braking and deceleration. Okay, deacceleration. So here what happens, wheels spin motor shaft via drivetrain. Okay, so reverse operation of the motoring. And here rotating rotor induces back EMF is generated. That back EMF is fed to the inverter. Then inverter will acts as a active rectifier, AC to DC, and that DC will be stored in the batteries. Okay, so here current flow from motor, inverter, battery. Okay, done. So then we have blending braking strategies. Okay, so here this is 100% regenerative braking. Okay, so there is no brake here. Okay, fully 100% regenerative braking here. Okay, now here you can see motor provides full braking torque. And next, moderate braking. So here what happens, regenerative is priority. Okay, major is regenerative braking. So some of the part will be for the normal brakings. Driver can brake and driver can slow down the vehicles using this 30% region. Okay, and next, hard braking. So here what happens, 30% regenerative braking will be done, 70% driver having the control based of the vehicle deaccelerations. Okay, now then emergency braking. Here what happens, 5% will be regenerative will work, and 95% will be from the driver itself. Okay, here ABS will be active. Okay, and regenerative will be very minimal. Okay, now so here red color is friction, hydraulic. Okay, so driver press the brake pedals means, so it will apply the friction to the brake pads, and there will be a speed will be reduced in the wheels. Okay, these are the multiple braking strategies in the electric vehicles. Okay, so here then comes battery SOC and charge discharge controls. Okay, now so here we are building the model in Simulink, MATLAB Simulink. So first we will use these relay modules. Okay, for switching the motor as a generator, and battery discharging and battery charging. Okay, this will be done using the relay modules. Then switching threshold 50. So this is battery state. Okay, if the battery state of charge is 20%, then act like motor will act as a generator. Okay, if the battery state of charge is above 80%, then the battery will feed the motor will rotate based on the input voltage from the battery. Okay, and here constant block, so it is used for the motor torque. And then battery charges, so here we will use battery module and we will check the state of charge and we will obtain the state of charge. So this is all about the Simulink library. Okay, so here we are going to build this circuit and we will check all the conditions. Okay, so here we are going to use a battery and the controller circuit, current source, relay module, gain block, DC machine, and a constant block and a scope. Okay, done. So let us start the simulation. Okay, so this one I will show you it in the simulations. Okay, done. So all of you open the MATLAB software and open the Simulink library. Open the MATLAB Simulink library. Why it is taking long time? So here we got the MATLAB Simulink model. Okay, so yes, so we are designing the regenerative braking system. regenerative braking system using DC machine and battery. Okay, so this is a project we are going to simulate now. Okay, now for simulating this module we required certain blocks. Okay, so now we will take the blocks for this simulation. Okay, first one is the DC machine. Search for DC machine on the Simulink library. So you will get the DC machine block here, add it to the model. So then we required battery. Search for battery. It is getting very slow. Okay, search for the battery. So here you will get the battery module. Add this block to the model. Okay, we got the battery module here. So then we required a module called controlled current source. Okay, search for controlled current source. So here you will get this block. It will be like arrow mark like block, this one. Add this block to the model. Okay, it is having 3 pins. Take correct one. So here there will be multiple blocks. So here there is a current control source. Okay, not this block. So you should take this one. Arrow inside there should be arrow mark. The terminal should be like yes, negative and positive. Okay, then we need relay module. Relay. Search for relay. You will get this relay. Add this relay module. This one. Okay, not this one. Inside the Simulink. The block inside the Simulink. So then a required power GUI block. Take the power GUI block. Add it to the model. Then we need scope block. Go to the sinks, take the scope block. Then if you need display means you can take display module. So then we go to the signal routings, take a bus selector here, bus selector, and then go to the math operations. Here you need to take gain block. So go to the math operation, take gain block, then go to the source. So here we need a constant block for the torque motor input. Add the constant block. Okay, so after that we will place every component in a different place. So when you are connecting the circuit, then you can use the particular module. Okay, we will place this battery here. Okay, so then we will connect this controlled current source, this one. So before this we need to flip this block. positive should be at the downside and negative should be on the upper side. Okay, so just select this block, click Ctrl R, okay, so then select this, Ctrl R, again Ctrl R. Okay, now so we will name it as I. Okay, so now connect this positive to the battery positive, this negative to the battery positive. Okay, and positive to negative like this. Then connect this constant block, this one here, constant block, to the S here. Okay, then we need to take DC machine. Okay, connect this DC machine positive of the armature to here. Okay, and relay we will take it later. So after this, armature negative will be connected to the positive here. Done. Then we will connect parallel to the field winding and armature winding. Both power supply we will connect it as same. Okay, so after this, go to the bus selector, connect this bus selector to the motor here, M, double click on the bus selector. So here there will be 3 options. Okay, so this one we will take it later. Okay, we need one more bus selector here for the battery. Okay, connect it to the M. So double click on this bus selector. Yes, so here we got 3 options, so you can take any 2. Okay, we required only SOC. So before that we will remove these 2 signals. Okay, remove this one also, and we will take SOC and the voltage, SOC and voltage, and click on OK here. Done. Yes, so then take this gain block. Here we need to connect it for SOC, connect it for SOC, and so after connecting the gain, yes, so here constant value must be 50, constant block value must be 50. Then click on OK here. Okay, okay, so after that double click on this gain block. So here we need to add 1/100 value, then click on OK. Done. So after this, take this relay block, connect it to the gain one. Okay, so here we need to change the relay values. Here we need to switch the motor for regenerative braking and the normal working based on the battery state of charge. Okay, let us assume if the battery state of charge is 80%, then the machine should act as a motor. Okay, when there is a battery percentage less than 40%, then the motor should work as generator. Okay, for that the switch on point must be 0.8, nothing but 80%. Okay, and switch off point must be 0.4, that is 40%. Done? Yes. So after this you can just click on the OK. Done? Yes. So and one more value we have missed, that is double click on this relay module. Okay, so here output when off, it should be minus 200, output when off. Okay, so then double click on this bus selector. So here we have connected the machine. Okay, double click here. So here we need to remove these two signals. So here we will take only speed value and the armature current. Okay, these two we will take from this bus selector. Click on OK. Done. So now we need 4 inputs for the scope. Okay, double click on the scope block. Go to settings here, and here number of axes, make it as 4. Click on OK, then close it. Yes, so we got 4 input pins for the scope block. Connect one by one. So first we will connect here speed, then armature current. Okay, then we will connect SOC, state of charge. Then we will use this voltage, input voltage. Okay, so after this double click on this battery module. Okay, so here the nominal voltage must be 200. Okay, nominal voltage must be 200, and here it should be battery type should be lithium ion. Okay, so here we should select lithium ion. Okay, now then here the rated capacity, it is 6.5. then initial state of charge. Okay, initial state of charge, it should be 100%. Okay, now so after this, yes, we are changing the batteries. Okay, so done. Then click on OK. Okay, so after this, just run the module and check the output. So here you can connect this display for the input voltage, or okay, let us connect it for speed. This is the final value. Okay, the final value will be displayed in the display modules. Okay, so after this the simulation stop time, we will make it as 1000. Okay, so then click on run button. We have got some error here. Okay, let us check it. Yes, so here we have missed one more connection, that is sorry. So here after this relay we need to connect this one connection, TL. Okay, so connect this TL. Okay, let us stop this one. Connect this TL to the relay output here, like this. This one we have missed earlier. Okay, connect this TL at the relay output here. Okay, then click on run. So check in your laptops. So make the simulation stop time as 1000. Okay, not 1. So here my laptop is very slow. That's why I have changed this simulation stop time to 1. Okay, but you will not get the exact output here. The expected output is like this. I will show you here. Okay, this one. This is the expected output. Okay, so you should make this simulation stop time to 1000 and run it. Okay, so now my laptop is very slow, that's why I will, so if I make this simulation time to 1000 and if I run means it will not speed up. Okay, so here is only 0%, it is showing 0%. Okay, so we will get the exact output here like this. Okay, I will explain here only, so let it be. Okay, see here. Okay, so here what happens, this is a voltage graph. Okay, now this is a state of charge, this is a speed, and this is a current. Okay, so here from 0 to 250 260 near. Okay, so it is a time. Okay, so x-axis is time, y-axis is for this graph it is current, for this speed, SO state of charge, this one voltage. Okay, so here what happens, the state of charge is nothing but for the battery ratings. Okay, so here 100%. Okay, when the speed is the speed increases. Okay, so when the electric vehicle is moving, let us consider the speed is 150. Okay, 150 rpm. Okay, let us say 150 rpm. So when the motor is running at 150 rpm in the constant load, so the state of charge, the battery will decrease, battery percentage will decrease. Okay, from 100% to 40%. So below that it will not go, because we have given the value in the relay module. Okay, that is 0.4. 0.4 is nothing but 40%. If the battery percentage comes to 40%, then again it will the motor will act as a generator here after 40%. The motor will not fed by the battery, so battery is fed by the motors. So now what happens, the motor will act as a generator, where the speed is speed increases, here the current will reduce, because there is a free energy, the motor is acting as a generator. That's why here the voltage is increasing. Okay, and state of charge will increase from 40% to 80% we will charge for the regenerative braking. Okay, and here after 80%, again it will the motor will act as a motors. Okay, it will not act as a generator, it will act as a motor. Again it will take the power supply from the battery. Okay, battery, and again the battery percentage will reduce from 80% to 40%. Okay, again when the battery percentage comes to 40%, motor acts as generator, battery charges. Again motor, if the battery is 80%, battery will fed the motor, and motor will consume the power in the battery will decrease. Okay, like this it will goes on charging and discharging. This is a discharging, this is a charging. Okay, again here discharge, charge, discharge, charge. Okay, so linear like parallelly you can see the voltage graph. When there is a generation, there is a high voltage. When there is a discharge, there is low voltage. Okay, when during generation there is high voltage, during discharge there is low voltage. Here also you can see speed. So during discharge it is normal speed. Okay, during regenerative braking the speed will be increased. Again when decreasing, when battery discharging time, the motor speed will normal. Again when is the battery is charging means the again speed will increase, like this. Okay, here you can see the current. Initially it will be 0. Okay, if the load is constant means current will be minimum. Okay, and here after some moment, so battery is charging here, then the current will becomes negative. Okay, negative in the sense it is generating the power. Okay, here back EMF will be generated from the motor acting as a generator, that's why current is negative. Okay, again when the battery is discharging it, the battery will the current value will be positive. Again if the battery is charging means the current value will negative, like this. Okay, like this the graph will be obtained at the output side. So now like I am not unable to show you in the live class. Okay, you can check it in your laptops after this class. I will also upload this video in the YouTube, there you can check it. So yes, so I started the simulation in 2 minutes ago, so now it is only 2%. Okay, that's why like try it in your laptops. Okay, so after that if it is not getting correct output means I will check it in next class. Okay, now so once I will reset this laptop. Okay, and restart, and I will refresh it. Okay, after that I will try it. So if it is getting the output means in tomorrow class I will show the outputs. Okay, done. Okay, so if you have any doubts related to this simulation models or any topic related to today's discussion, just you can ask. Okay, and one more thing, I will share the assignment questions in the classroom. Okay, try to solve them. Okay, now then we will save this module on the desktop folder. Very slow.